Intermediate Algebra Section 1.6, taking a look at some nomenclature that's used in algebra and also dealing with positive and negative exponents. And in this first example, they're asking us to evaluate the following when x is a negative 3. By definition, anything raised to the 0 power is equal to 1. So regardless what that x was, other than 0, 0 to the 0 power is undefined, but here we have an answer of 1. In terms of confusion, we have to be sure that we ask ourselves what is raised to the 0 power, and in this example here it is only the x that is raised to the 0 power. Otherwise there'd be parentheses around it like this third example over here. So putting in a negative 3 in place of x and raising it to the 0 power, which we just saw a minute ago was a 1, we end up with 5 times 1, which results in 5. However, on this third problem, what's raised to the 0 power is that whole quantity. So replacing the x with the given value, following order of operations, multiplying, we get a negative 6, and it really, because of the fact that this whole thing is raised to the 0 power, doesn't matter what's in here. Our result, because of it being raised to the 0 power, is equal to 1. So watching the nomenclature used in algebra, these are not equivalent expressions in the fact that it's the whole quantity raised to the 0 power and only the x that's raised to the 0 power, following your order of operations and making sure you ask yourself what's raised to the power will avoid some errors in the future. We also want to take a look at eliminating negative exponents, and we use our property of integer exponents. When you have a term or a base to a negative exponent, we can eliminate it by dropping it to the denominator. And if it's negative in the denominator, we can bring it to the numerator to eliminate the negative exponents there. So here we have 3 to the negative 2. To eliminate the negative exponent, we will drop that to the denominator. We no longer have negative, and we can simplify. 3 to the second power means 3 times 3, and this is just another way of expressing the value 1/9. We have negative 2 raised to the negative 4th power. A negative exponent does not in itself indicate that an expression is negative. So here, to eliminate the negative exponent, we will just simply take that expression and put it in the denominator. Something to the 4th power means that thing times itself 4 times, and let me write that out just to illustrate what we have. Maybe extend my fraction bar there. We have a series of an even number of negatives multiplied together, which is positive. A negative times a negative is positive, times a negative would be a negative, but that 4th negative turns it into positive. And 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is a result of 16. So our final answer is 1/16 for this problem. Here's a case of asking yourself what's raised to the power, and it is only the x that's raised to the negative 3. Otherwise, there would have been parentheses around the 2 as well. So to eliminate the negative exponent, the 2 stays put, but the x to the negative 3rd, to avoid the negative exponent, needs to be put in the denominator. In this last example, we have a negative exponent in the denominator, and to eliminate a negative exponent that's in the denominator, it needs to go to the numerator, which has a 1. 1 times a to the 7th would be a to the 7th.